Good morning. Today we are going to see interfacing of 8051 with different devices. Let us start with the interfacing of 8051 with LCD. Now if you check this particular diagram, on the left hand side 8051 IC is there, and out of this 8051 we have utilized port 1 and port 3. 8 pins of port 1 are connected to the data lines of LCD, which is available on the right hand side, and 3 pins of port 3 are connected to the control lines, that is register select, read write and enable pin. And the right hand side, if you check out, potentiometer is connected to the VCC and VSS and VEE. And if you check out this one, it is utilized to adjust the intensity of the LCD. Let us see the use of various control pins. There are three control pins, that is RS register select, RW that is read write and E that is enable. Now there are two values which will be sending to the LCD. That values will be either considered as a command or data, and that decision is done based on this RS value. If RS value is equal to 0, then it will work as a command register. If RS value is equal to 1, then it will work as a data register. Next one, RW. Whether we are interested to read from the LCD or write to the LCD, it will be decided based on this particular value. If RW value is 0, we are interested to write to the LCD, and if RW is equal to 1, we are interested to read from the LCD. So at present we are interested only in writing the content on the LCD, so that's why we are going to make RW is equal to 0 only. Next one, enable line. To enable the LCD, we have to send high to low pulse to latch the data into the LCD. So to send the high to low pulse, we have to first of all set the value and then clear the particular value, so that high to low pulse will be sent over there. Let us see how this particular commands are there. There are different commands. Each command is having different function. For example, if we send the value 01 hex, it is indicating that clear LCD display. If we send 06 hex, it indicates that we are shifting the cursor towards right after every data write to display. If we send 0E hex, it indicates that LCD is on and cursor is on. If we send 0C hex, it indicates that LCD on, cursor off. If we send 0F hex, it indicates that LCD on, blinking cursor. Out of these particular three commands, we are going to utilize only one particular command. And further, there are two lines on the LCD. First line is having the location 80 hex. On each line there are 16 characters you can display over there. So if you are interested to display from the 0th position, the address of that particular position is 80 hex. So it indicates that cursor is in position 0 on line 1. If we send 0C0 hex, it indicates that you are interested to display on the second line 0th position, like this. And last one, 38 hex, it indicates that you are interested to initialize it as a 2-line LCD which is having 5 by 7 matrix display. Let us see how the program is done over there. First of all, we are going to originate zero, means from where your program should store. So we have started with org 0000 hex, means from this particular location my program will be stored. Next one, we have to initialize the port 1 and port 3 as output, because we are going to send the value from 8051 to LCD, means port should act as a output pins. So that's why if you check out over here, we have initialized the port 1 as a output by sending 00 hex. Similarly, port 3 we have sent the value 00 hex, which will initialize both these ports as a output port. And if you send instead of 00 hex 0ff hex, we know that it will act as the input port. Next one, as we saw in the previous slide, that there are two register, means register can be work as a command register or data register. So if we are interested in command register, we have to initialize the value of rs like this, that is rs should be 0 to indicate that is command register, and rs value should be 1 to indicate data register. So that only we are going to utilize over here. So let us start with the command first, because without sending the command you can't initialize what you want to display over there. Move dptr comma hash mycmd. This indicates that whatever mycmd location content is there, that content you are going to move to the dptr, means from that particular address whatever commands are there, that will be stored. And that is done in this way. Just a sec, I will show you. My cmd is there, means my data is stored over here. Sorry, data not command is stored over here like this. So 38 0e 01 06 80 hex and last, that is 0, so that it indicates that commands are ended. So like this you have to store the particular command value. So mycmd is the location where that particular commands are stored. So initially I will be starting with clear accumulator content, so that I can utilize this particular instruction in a proper way, that is move c a comma at the rate a plus dptr. So initially a value is 0, so 0 plus dptr is whatever dptr location is there, that is my cmd location is there, that will be content of my cmd location will be moved to the accumulator. So what is our initial content of the my cmd location? 38 hex is the initial content, so that will be moved to the accumulator. Then we are calling the command, because that I'm interested to use that particular value as a command, so that's why we are calling the command subroutine. After sending that calling that command subroutine, we have to call the delay, because we have to give some time to the LCD so that it should read that particular command or whatever data is there. Then increment dptr. Now whenever you increment the dptr, now my location will be shifted to this particular location, because this is your first location, this is your second location, this is third, fourth and fifth, and last one is 0. So once you read this particular value, my aim is to read the second value, which is nothing but 0e hex. So that's why we have incremented the dptr. After incrementing the dptr, it will check whether the data is 0 or non-zero. If the data is 0, it will shift to the data subroutine, that is here. So when my 0 value will be reached, after reading this first location, second, third, fourth and fifth, means total 5 content. After reading the 5 content, whatever 6th content is there, that is 0. So whenever this particular loop is executing for the sixth time, at that time it will come out of this particular loop and it will jump to the data subroutine. Otherwise, it will be in this particular A0 loop only. Next, in data subroutine, we are going to call the value which you want to display. So move dptr comma hash my data is there. So if you check out over here, this is the value, or this is the message which I am interested to display. My data db, that is data byte, and in double inverted comma whatever message you want to display, that should be mentioned over here. So I am interested to display India, so that's why I have put up here India, and after that put a comma and last, that is 0, so that it indicates the end of that particular reading the data. So similar to the command subroutine, this data subroutine is there where you are going to call the data write, then call delay to give some time, increment the dptr similar to the command. Next, jz-a2, which indicates that whatever data you want to display, that is over, and sjump a1. This loop will be executed continuously unless the last value is reached, that is this 0 is reached. So likewise this particular routine is there. After this one, whatever data subroutine is there or command subroutine is there, for that we have to write small program. So if you check out over here, command subroutine move p1 comma a. So whatever a value is received over here, that is either in this particular case or in this particular case, whatever this value is received in the accumulator, that we are going to send to the p1. So at present this is the command subroutine. So whatever value we have received in this particular loop in the accumulator, that we are going to take to the port 1. So once we take in the port 1, we are interested to initialize that as a command register. So that's why clear p3.0. Why we have sent clear p3.0? Because if you check out over here, p3.0 is connected to the rs. So whenever rs value is 0, at that time it will work as a command register, and whenever rs value is equal to 1, it will work as a data register, and rw must be 0 because we are interested to write to the lcd only. So if you check out over here, clear p3.0 we have done, clear p3.1 is done over here, so that rs value will be 0 over here and rw must be also 0 because we are interested to write to the lcd. After this, to enable the particular lcd, we have to send high to low pulse. How to send high to low pulse? First of all, we have to set the p3.2 pin. Whenever we are setting this one line, high level line will be sent over there, generated will be there, and after that we are calling the delay. Due to this delay, that value p3.2 will be set only, and after completion of this delay, we are sending clear p3.2. Means what will happen, high to low pulse will be generated due to this particular thing, and once this subroutine is over, we are going to return to the main program. So main program means what, where we are going to return after calling this particular subroutine, it will come back to the a call delay, and that delay will be executed like this. Similarly, data write will be there, and what will be done over here, whatever a content is available in the data write, that is this particular case, that value we are going to send to the port 1. And next one is, now this value should be considered as a data, so that's why we are sending high value over there, that is set be p3.0, so that rs value will be 1. So whenever rs value is 1, at that time it will work as a data register. All other thing will remain same, that is we are interested to write only, we are we have to send high to low pulse only and then return. Final, that is nothing but delay subroutine. Generally, it is better to keep the delay of 20 milliseconds. So once you keep that particular delay, that is sufficient. So like this, your this particular program will be applicable to all the messages which you want to display on the first line. Now, whenever I want to change this particular message, let us say that I want to display SK and SCOE. Just I have to replace India by SK and SCOE. So like this, whatever message you want to display, you have to write over here. And let us say that I am interested to display on the second line. So whenever I am interested to display on the second line, instead of 80 hex, this value should be now C0 hex, that is 0C0 hex, which indicates that you are interested to display on the second line. So like this, LCD program will work, and thank you.